All right, today we are going to trace the incredible story of artificial intelligence. We're talking about a journey that spans nearly 100 years, from the very first philosophical questions about thinking machines, all the way up to the powerful generative models that are, well, they're changing our world as we speak. It really feels like it all happened overnight, doesn't it? One minute, AI is science fiction, and the next, it's everywhere. It's helping write our emails, it's creating breathtaking art, and it's powering this technological revolution that's moving at a pace that is just wow. And that's the real question, right? This isn't some brand new idea. The concepts that are exploding today have roots that go way, way back to the very dawn of computing. So, how on earth did we get from these abstract, theoretical ideas to the tools that we are literally using every single day? To really understand where we are now, we have to walk through the past. And this timeline here, it lays out the whole journey for us. We're going to start with the theoretical foundations, move through that first exciting wave, and the, let's say, less exciting AI winter, and then land on the deep learning revolution that brought us right here to today. So let's start at the very beginning. I'm talking about the dreamers and the theorists, the people who first even imagined what a thinking machine could possibly be. This is where the seed of the entire field was planted. And our journey really kicks off with this man, Alan Turing. Long before anyone had a microchip, he was wrestling with the one question that still drives the field today. His work basically provided the intellectual blueprint for everything, and I mean everything, that was to come. And this was his masterstroke, the Turing machine. Now, what's so important to understand is that this wasn't a physical, clunky piece of hardware. Nope, it was a thought experiment, a beautiful, abstract model of a device that could, in theory, compute anything that is computable. This single concept is the bedrock of every single computer you've ever laid your hands on. And the elegance of it is just how simple it is. The machine just reads a symbol from a tape, looks up a rule from a list, and then writes a new symbol. That's it. But by repeating these incredibly simple steps over and over, this theoretical device could solve unbelievably complex problems. It proved that computation could be mechanized. Okay, so let's see how these wild theories started to become the first real attempts at AI. Now, this was a period of incredible optimism, some truly groundbreaking ideas, but it was also a time for a few serious reality checks. So, meet the perceptron, created by Frank Rosenblatt. This thing was a massive leap forward. Why? Because it wasn't just programmed with a set of rigid rules, it was actually designed to learn. And that was a completely radical departure from how people thought about computing at the time. The inspiration here was purely biological. The perceptron was a very basic mimic of how neurons connect in the brain. By adjusting the strength of these connections, based on whether its answers were right or wrong, it could gradually teach itself to classify simple patterns. The key idea here is that it learned from experience. At the same time, over in another lab, we had Eliza. This was one of the world's very first chatbots, and it was shockingly effective. By using some clever pattern-matching tricks, it could simulate a conversation with a psychotherapist. Now, it didn't understand a single word, but it showed that human-computer interaction could feel, well, human. But here's where the story turns. The promise was absolutely enormous, but the computational power and the actual algorithms, they just weren't there yet. The perceptron couldn't solve really complex problems, and Eliza, well, it was really just a clever parlor trick. As those big promises went unfulfilled, the funding dried up, and the whole field entered this long, cold period of stagnation we now call the AI winter. But while things were pretty quiet on the surface, a really crucial breakthrough was happening in the background. This next development would lay the groundwork for the end of that AI winter and, really, set the stage for everything we see today. The key, the secret sauce, was an algorithm called backpropagation. It elegantly solved a massive problem. How in the world do you train a deep neural network, one with many, many layers? Backpropagation gave researchers a mathematical way to trace an error all the way backward through the network, figuring out precisely how much each connection was to blame, and then tweaking it just right. And this is the point you have to get. Without this algorithm, the deep, multi-layered networks that power pretty much all modern AI simply wouldn't be trainable. It was the missing mathematical engine from that first wave, and its refinement, quietly but surely, ended the AI winter.
Okay, so now we have this powerful new engine for learning. And at the same time, computer hardware is getting exponentially faster. The stage was set for AI to finally step out of the lab and onto the world stage. And how did it do that? By challenging us, humanity, at some of our most intellectually demanding games.
These were the shots heard round the world. In 1997, Deep Blue's victory over Kasparov was this monumental moment, a showcase of sheer brute computational force. But AlphaGo's victory in 2016, that was arguably even more profound. See, Go is way too complex for brute force calculation. It requires something like intuition. AlphaGo demonstrated that an AI could develop strategies that no human had ever even dreamed of.
So, what was powering this incredible leap? Well, a huge factor was new architectures, like AlexNet back in 2012. It absolutely demolished an image recognition competition by using a deep neural network that was trained on, get this, graphics processing units, or GPUs, the same chips used for video games. This combo, deep networks and specialized hardware, was like pouring gasoline on the fire of the AI revolution. And that brings us to the final and most recent piece of our puzzle. This is the breakthrough that directly enables the chatbots like ChatGPT and this entire generative AI explosion that we're all living through right now. So in 2017, a landmark paper introduced something called the transformer. Before this, models had to process text word by word in a line, and they'd often lose the context. The transformer's self-attention mechanism changed everything. It allowed the model to look at all the words in a sentence at the same time and figure out which ones were most important to understanding the meaning. Kind of like how you might highlight the key phrases in a book. This was a total game changer.
This new architecture could process language with a level of nuance and contextual awareness that was just impossible before. Almost overnight, it became the undisputed foundation, the backbone for pretty much every advanced language AI system out there. And you can draw a straight line from that paper to today. The T in GPT, yeah, that stands for transformer. This one piece of architecture, when combined with massive data sets and unimaginable computing power, unlocked the ability not just to understand language, but to generate it coherently, creatively, and on a scale we'd never seen before. So there you have it. From Turing's abstract theoretical machine to today's creative powerhouses, what a long and fascinating journey it's been. We've watched AI evolve from a philosophical question into a powerful tool that can master logic and even mimic creativity. The history so far is written, but the next chapter, well, that's just beginning. Thanks for joining me on this explainer.